Okay, this is the chapter of waves, more specifically your general properties of waves itself. So first thing we need to know is what are waves. So if you were to recall back to your energy chapter itself, we know that one of the method or the process where we transfer energy is through propagation of waves. Now propagation just means motion of waves, so that is why the first part we are learning about is what is a wave motion. Okay, so wave motion or wave more specifically is just a disturbance that causes this periodic motion. Basically just periodic motion just means repeated motion. Okay, repeated motion itself. So you mean like a pendulum, like a back and forth, like a pendulum swinging back and forth. This is what we call repeated motion itself. So waves, as a form of transferring energy, they transfer through vibrations, so very important, through vibrations. And the thing is, there is no transfer of particles or matter itself. So even if you drop a pebble inside a puddle itself, the wave will actually move outwards. So if you have any kind of, like for example, like a leaf, right? You have the surface of the water itself. If there is a leaf that is right up on it, what happens is that the leaf will just move up and down, but it won't actually move with the wave itself. So it just move about the original horizontal position and it won't move with the wave. Okay, so you can take a look at that. And we actually have two different types of waves itself. We have what we call a transverse wave and a longitudinal wave. So sometimes students find it very difficult to memorize it. So for me, I remember it as transverse is top down. So basically this one, you can see that this one is perpendicular. Okay, so one of the thing is you look at here, it looks kind of like perpendicular, right? If you just flip it upside down. And then for longitudinal itself, it is actually the parallel. Okay, so what specifically, which part is parallel, which part is perpendicular? Let's write it down. Basically, we are interested in two things: wave motion and particle motion, because we know that your particles or your matter itself, they don't move, right? However, there is because of the disturbance itself, there is actually some fluctuation in between them. So if you are transverse, you will just be perpendicular for this wave motion, perpendicular to particle motion. Then if you are longitudinal, your wave motion is just parallel to particle motion itself. So you can see the definition right below here. Transverse waves are just waves that travel or move perpendicular to the direction of your particle vibration. So maybe you can just add the word here, particle vibration. Okay, so this one, up and down, right? Don't write this. Okay, because you're set 3, upper set already, or set 4. Nobody writes up and down, left and right. Why? Because up and down is very, very relative. Now, if you look at the setup below, right? Yes, this direction up and down, right? But what happens if I were to move my hand left and right? You'll notice that the wave itself, the displacement of your particles or the rope itself is also now left to right. So you cannot say that it is now up and down, right? But it is still a transverse wave. So the key word is perpendicular. Okay, it's perpendicular. You must use the word perpendicular. Don't write up and down. Okay, now water waves, light waves, and electromagnetic waves are all transverse waves. So these two are electromagnetic waves. They can travel in vacuum. Okay, so do take note about this. So you can see that this dotted line that I just drew is the equilibrium position, which means if I don't have the wave, if I don't have the disturbance in place, my rope would be in the original position. So, but you can see that the rope is actually going to move up and down or along that axis itself. Okay, you can see when we say up and down itself is very, very relative, but in terms of answering question itself, please use the word perpendicular. All right. Then for longitudinal waves itself, we will actually move parallel to the direction of motion itself. Same thing, can you add in the word particle vibration? Okay, so wave motion parallel to particle vibration. You move in a back and forth. Same thing, back and forth is very, very relative. Try to write parallel as much as you can. So in your chapter itself or in your syllabus itself, the only one you should learn would be sound waves. And sound waves, basically, they all cannot travel in vacuum. Okay, but if you use a slinky itself like this, you can actually form longitudinal waves. However, mostly in your syllabus, we are using sound waves itself. Now, so if you notice, we do have a few graphs that you can take a look, right? So if you were to notice, if you look at that same point here, directly on top, or the point 1, 2, and 3, right? What happens when the wave moves to the right? So when you want to draw that the wave moves to the right, you take this point, you shift it to the right. You take this, so every single point you have, you shift it to the right slightly. So you will notice that when I draw it, so you can just imagine it's as if I took this wave and I shift it to the right. So if you notice, if you were to shift it to the right like what I just did, right, can you see that this particle will be right here? After the wave has traveled, this particle will now be down here. So you can see basically when my wave moves to the right, different particles will behave differently. So this fella here will actually move down. So wave motion is moving to the right, right? Whereas the particle motion, the purple color ones, they are actually moving about perpendicular to the direction of wave motion. They are moving about their equilibrium position, which is at the 0 point. Okay, so you can see over here, this is what happens as the wave moves to the right. You can see that the particles, they interact differently and they behave differently itself. Okay, so below here you have your diagram and you have the wave here. So now the wave, they tell you, is moving to the right. So you can just imagine I have a wave like this, right? What happens when I move it to the right? So when I move it to the right, can you see that the particles P will move down, whereas Q will move up? So how do we phrase it itself? We will just say that points P will be displaced towards its equilibrium position, while point Q will be displaced towards its positive maximum displacement. Okay, like this. Please don't write it moved down, it moved up. Okay, so I know some schools don't mind that the phrasing is a little bit less, not so strict, but this is very, very important that you write this down, because if you don't do according to this, you actually get penalized. So you need to be very, very careful about how you phrase the answers itself. Okay.